Question number 5. We have a circular coil of radius 30 centimeters. So this is the radius, 40 number of turns. This is N. A uniform magnetic field is applied perpendicular to the plane of the coil. If the coil has a resistance of 5 ohm, determine the magnitude of induced current in the following conditions. So the magnitude of magnetic field increase uniformly from 0 to 0.6 Tesla in 7.7 seconds. So, right. Okay, based on the question, we know that the magnetic field is perpendicular to the plane of the coil. So it's gonna be, again, what we've learned before. The vector is gonna be parallel to the magnetic field. So that is the situation lah. And then we have to determine the induced EMF when the magnetic field is increased from 0 to 0.6 Tesla. 0.6 Tesla in 0.7 seconds. Okay, so for this one, induced EMF, kita akan guna negative N dV over dV over dt lah. Okay, but basically if we simplify it, we will then get this equation here. So since this is the magnetic field that is changing, A will be in front, so this is the rate of change of magnetic field over the time. Okay, let me just check my notes if I've did it the same way. Okay, I've written it here lah. Okay, right, so lepas tu kita dapat yang ini. So we just have to expand there lah, okay? I'm just gonna expand this bit here, final minus initial, just divide by the time tadi lah, okay? So kamu akan dapat negative N is 40, area is pi r square, r is 0.3 square ya. Then kamu akan dapat 0.6 minus 0 divide by the time, which is 0.7. 0.6 minus 0. Kan, tu kan. 0.6 minus 0, okay, divide by 0.7. Alright. Then you will get the induced EMF to be equal to negative 9.69 volt. Okay? Okay, lepas tu dia minta apa? Dia minta then the coil is stretched until dia minta determine the magnitude of induced current berapa pula. Astaga. Okay, dia minta induced current. Okay, tapi betul lah, kita just perlu minta cari induced EMF dulu. Kenapa kita perlu cari induced EMF dulu? Because we are going to use this equation here, IR. EMF equal to IR, where I is equal to EMF over R. So EMF is equal to 9.69 divided by the resistor, which is equal to 5 ohm. So the current here is going to be equal to 1.94 ampere. Okay. Next, the coil is stretched until its area is nearly 0 in 0.8 seconds. Alright. So the initial area is basically the pi r square just now, which is 0.3 square. And then the final area is 0. Oops, my pen. Okay. So the time it took to do this is 0.8 seconds. Alright. So for this one, we are going to use negative NB dA over dt lah. So this is negative NB, area final minus area initial divided by the time. So negative 40. What is the value of B? The value of B is given as 0.6 Tesla. Is it given? Yeah. Okay, it's given as 0.6 Tesla, and then this is just 0 minus pi 0.3 square divided by the time, which is 0.8. So you'll get the induced EMF to be equal to 8.48 volt. But now we are looking for the current, so this is just EMF divided by R. So this is 8.48 divided by the voltage, resistor, which is 5 ohm. So you'll get the current to be equal to 1.7 ampere. Alright, Okay, so that is the solution for question number 5.